Hi, welcome to our Fireside chat on Efficiency Unlocked, the Power of Synthetic Data in Modern Enterprises. I'm Alex Watson. I'm a co-founder and chief product officer at Gretel AI, and I'll be the moderator today. Joining us, we have two distinguished experts who will be sharing their opinions and experiences with synthetic data. Let me first introduce Varun Nakra and Raghavan Muthuraganathan. Varun, if you want to kick it off with a quick intro, please.
Sure. Thanks, Alex, for welcoming us. So I currently I'm working with Deutsche Bank. I have worked in financial industry and primarily in banking and credit risk modeling. So I have experience with a lot of quantitative methods and statistical analyses, machine learning, etc., as it applies to credit risk per se. But I have worked with in consulting as well. So I've a bit of experience with insurance and other sort of other companies in the US and in the UK as well. So yeah, that's my sort of a wholesome like data science background. Yeah.
Hey Alex, happy to be in this meeting. My name is Raghavan, and nice to meet you, Varun. I've been with search industry for a while. I started my career at Microsoft Bing. Right now, I am working for LinkedIn Search. I lead the LinkedIn Search AI team. I have worked across the stack for search engines, starting from type ahead, query understanding, spell correction, ranking, retrieval, etc. So happy to be here.
Great, thank you. So I think we'll start with a little bit of context before we jump into our discussion and questions today. For a little bit of background on Gretel, we are a synthetic data platform used by developers and really a big focus on addressing bottlenecks when it comes to AI. And those bottlenecks can be around access typically that we see to high quality data. And what we're going to be talking about today is how synthetic data, broadly and across different industries can be used to address these types of bottlenecks. Like how do you get access to sensitive data you might not have been able to work with before? How do you improve data for AI use cases? How do you make the most use of the limited data that you might have? And then also talking about some of the really neat things at a business level perspective. So some of the strategies for implementation, different methods for measuring the ROI that you get from synthetic data from two leaders at large companies that have worked on this at scale. And then some of the approaches to overcoming common challenges you see around synthetic data implementation. Let's jump right in. I think first, let's talk about operational efficiency and cost reduction. So Varun, I'll start with you. Question for you is, how have you seen synthetic data being used to enhance operational efficiency in the finance and banking industry?
Sure. I think it's a great question. Before I speak on synthetic data, I would also clarify that there are certain areas of the financial industry which are more adaptable and amenable to new technology, new changes in things like AI and machine learning and the use of synthetic data. But like a larger portion of the banking industry is still slow to adapt to these changes. Having said that, I do see a lot of use cases in which using synthetic data, you could achieve a good amount of like operational efficiency per se. So for instance, I'll give you an example that when banks do lend, and it's known as it's known as credit risk. When you're lending, there's a certain amount of risks that you are undertaking by lending money to different borrowers. So there would be times when banks want to expand and they have no idea. It's a new geography, so they have no idea of the risk. How would they account for that geography? They have, primarily speaking, they have no data to model or to understand what would happen. So this would mean that, okay, they would experiment, they would buy data, or they would start slowly, which means that there's a lot of operational inefficiency, so to speak, for them to achieve the kind of ROI that they're expecting in growing in that geography and growing in that particular space. So if there were like a robust solution of synthetic data, which could be modeled and could be used, they could grow faster.
So essentially, the use case you're describing is simulations, like running simulations on data where data may not exist, or you don't, as your business, have that data, but you might be able to leverage knowledge, as you were mentioning, that could come from external sources or generate synthetically.
Correct. So at the moment, like banks do buy data, like they're reliant on external data providers all the time. But these providers pool different data, so that is also actual data. But then the next step comes that how would you prove that okay, this data matches to what you're trying to do? Because not every data is going to give you the same results. So there is, in terms of like, I'm trying to answer the question of operational efficiency. In terms of that, it becomes a bit inefficient because there are costs involved, there's bottlenecks involved, there are contracts involved, there's a back and forth, and then you will model, and then you will come to a solution, and then you will implement it. So let's say if let's say there are like generative adversarial networks and all these fancy sort of algorithms, if they become robust enough, and if you could train them that okay, this is what let's say my default distribution looks like in a particular geography, how would I model it for a new geography for which I have really limited data? And then I use that GAN to train and then make a better prediction to at least kickstart my business rather than being reliant on many other different external parties for me to get that leverage.
Here we're talking about credit risk. I've heard a lot of similar use cases in fraud, where an area is talking about expanding into a new area. Could you help differentiate a little bit between how you think about credit risk and how you think about fraud in the financial industry?
Great question. So I do have like a really limited amount of experience with fraud. So what I saw was that fraud is exceptionally changing really fast, because when fraud is happening, these are bad actors. These are not people needing money, which is happening in creditors, right? So the underlying data is changing. So the way they want to change their strategies, there's seasonality in it. So if it's like close to September season, there's sales on Amazon Prime, you would see all these cards being more susceptible to fraudulent policies by new fraud attackers. And there's geographical challenges. Some countries are more susceptible to this. They have less regulations, etc. So the underlying business and the way things work are really different to credit risk. Credit risk is more stable. You can do more stable stuff, and you can implement a solution for a longer period of time than in fraud risk.
Thank you. That's very, very helpful. Going to switch over to Raghavan here in just a second. I forgot to mention earlier, I know there's a lot of people on the stream right now that are going to have questions. Please feel free to drop any questions you might have right into the chat. We will have a section at the end. We'll try to answer as many questions as we can. The ones we're not able to get to, we will follow up with after. So please drop questions in. We're looking forward to the discussion later. Raghavan, very similar question for you. If you could share specific instances or things that you've seen with efficiency gains in AI in the search space with respect to synthetic data.
Yeah, let me try and give you a very okay. Before I start, I would like to say search engines employ a vast army of humans to evaluate the quality. They are called search raters or annotators, etc., etc. They are trained in for a given query and a list of 10 blue links or web page links. They are trained to annotate judge that URL, whether that URL is good, bad, fair, or perfect, etc. on a Likert scale. Usually a 6-point Likert scale or 4-point Likert scale, depending on what the search engine wants to do. And this is how search engines evaluate their quality on a regular basis. Now, where does synthetic data help here is, most of the times you are searching for navigational queries like Facebook, you go to facebook.com, or Twitter, you go to twitter.com. That's the challenge is not there. The challenge is in the long tail of queries, for which the volume of queries are very small. For example, a micro segment that I can think of is current movie releases. Let's say there are movie releases in the last 6 weeks or so, and people would be searching for that movie name, review, movie name, Rotten Tomatoes. So when you have that, and there are so many different query segments, tail query segments. An example of a query segment is celebrity query. Celebrity query is usually not a tail query. It has substantial volume, like Justin Bieber is a celebrity query, Katy Perry is a celebrity query, etc. But for these long tail query segments, where you are comparing or say current movie releases, there isn't enough representation on the data set that you use to send to these trained annotators to evaluate the quality of search engines. That's where synthetic data would help. For example, you could, let me think of a really tailish health queries. I know most of us, as soon as we see a symptom, we would go Google it, and that's still a tail query in my opinion. And let's say we want to improve the quality of search engines. For that, we could use synthetic data to generate example queries and increase the volume substantially, so that then we can look at the search engine results for those specific queries and send it to the annotator.
So this
So
would be an alternative. Is it right to think of it, right? Like, I guess a couple ways that you could get this data would be either, waiting to collect that data somehow through your search system. You could be paying human annotators to generate that data, or you could generate it synthetically. Is that correct?
exactly.
Gotcha.
So
And advantages to the synthetic, if you could maybe go over some of the advantages you would see to a synthetic data generation approach there.
So it reduces time in the first place. It reduces time because and also cost, right? Because you don't have to have human in the loop to imagine and generate these queries. Now you could use probably a large language model to generate these synthetic queries. So handling long tail scenarios. And the second advantage that I can see is that it leads to faster model development or faster iterations, quality iterations. Once you have the data in hand, for that micro segment, for that long tail segment, you can train a specific model for that segment and improve your search engine quality. So advantages are faster quality iterations, cost reduction, cost reduction and faster quality iterations for these long tail scenarios are the two advantages that come to my mind.
That's great.
Additionally, I also see a privacy angle here, because now once you have defined that long tail query segment, you are not generating sensitive user information, but like you're not using actual real user data, but you are letting LLMs or the models that you're using to generate the synthetic data, which is not synthetic data set that way allows us not to expose sensitive user information.
Yeah, that's good
So
feedback. Maybe just to to ask on the other side of that, like, what concerns would you see, or what gotchas or things to look out for would you have if you are looking at synthetic data in the search space?
define your segment for this specific examples. Define your segment thoroughly. So you should know what you are generating your synthetic data for, and you should know how you are measuring your quality. So you cannot take that for granted. Just because you have a large language model at your disposal, you cannot take that for granted. So that would be my define your goal.
Yeah,
And define
you have to know what you want to accomplish, and don't
Yes.
just prompt ChatGPT to generate the data for you.
Exactly.
Cool.
So-
Brent, I'm curious also in the finance space, if you have any areas to look out for, gotchas, things to be really careful about that you've observed when you're thinking about synthetic data as part of your strategy.
Oh yeah, for sure. So there are like multiple use cases. Use cases, by use cases I mean like quantitative modeling problems, which we face in credit risk and also in market risk and other areas of the financial industry, which are difficult to solve. And they're difficult to solve because there's a paucity of data. So it's quite related to what Raghavan said, that okay, there's a long tail search query. Similarly, like there are long tail loss distributions, and those loss distributions are long tail, which means that the probability of that one particular event being happening is so low, but if it happens, the loss will be really high. So there's a fat long tail, which is really difficult to model. And most of the times, operational risk and market risk, they are more interested in what's happening at the 99.9th percentile. Because if I could model that, I would know that, okay, this is the amount of leverage I have, this is the amount of capital I need, this is the amount of risk I'm undertaking in using that financial instrument, whether it's lending money, whether it's manipulating the markets, or like doing anything related to that. So with these models, if we have additional dimension of synthetic data, I think the underlying question becomes, how much do we trust what is coming out of that model, which is using the synthetic data? Like, how do we make sure that this is trustworthy? So let alone synthetic data, even if like we are building other kinds of models, which are more traditional models, there's a whole lot of process starting from model development to validation to governance to regulatory checks to confirming that, okay, the steps that were undertaken during the model development are justifiable, explainable, interpretable, and defendable. And then if a customer comes and whosoever gets the end impact of your modeling decision, he comes and challenges it, you are able to defend it. So there are a lot of all these areas which will have, you're adding another dimension of synthetic data into all these areas. So all these areas will have to be considered under that different lens. Like, how do we validate the models more robustly? Do we need to change the validation procedures? Do we need a mix of traditional methods and some more sophisticated algorithms that use synthetic data? And at the same time, how do we measure that? Are we actually solving the problem, first of all? And secondly, how efficiently are we solving the problem? Like, what is the ROI in that synthetic data? So there are lots of these open questions that would come up.
Gotcha. Really interesting point. So maybe just recapping some of the big points I heard here. Synthetic data is very useful, particularly for the long tail, both in the credit risk and in the search space. But then there's the risk of, are we introducing new biases or perpetuating biases that you wouldn't necessarily want to do in the data? So it's something you need to keep a careful eye on as you go. That's awesome. Thanks for walking through that. Maybe we'll move on to the next section here. So talking about scalability and ROI. And the question going back to Raghavan, what role would you say that synthetic data plays in scaling search AI operations?
I'd go back to the previous example. So you need, in search, for you to develop a high quality ranker, you not only need large volumes of data, but you also need a diverse representation of the data. So I can clearly see that synthetic data set solves for that second problem, which is to ensure that there is enough representation across the board. Let me think of a specific, okay, let's say most of search engines are in English, but search engines also support other languages if you want to search in a specific language. Now, and one way synthetic data can simply help there is just learn from English to that specific market and be able to generate queries and query set for scraping. The process that I said where you generate a data set of queries and then scrape the URL, send it to experts to judge. It can simply learn from what's going on in the English market to a low resource market. Of course, there may be some learnings that you will have because these English market and that market may not be the same. There might be differences, but it gives you a start. It gives a point somewhere to start, as opposed to drawing a blank. So in internationalization, especially for low resource languages, I can see synthetic data providing a head start. And also, I can see, I'm not sure if you would label this as synthetic data, but in my opinion, anything that is not organic and it's coming through LLM is a synthetic data. So going by that argument, I can see, and I already know that several search engines are employing LLMs to judge their quality instead of humans. For example, say, assume that we three are experts in evaluating search engines, and we are asked to evaluate, 1,000 queries and 10 URLs, so that each of us produce, say, 10,000 data points. I evaluate some 1,000 queries and the corresponding 10 URLs. You evaluate some 1,000 queries and the corresponding 10 URLs. And Varun evaluates another 1,000 queries and the corresponding 10 URLs. This can be used to do some few shot training for another LLM. And once the LLM and we are in a decent agreement in terms of evaluation, then LLMs can be used to do the annotation, to do the rating, effectively removing human in the loop. This is not synthetic training data generation, but synthetic evaluation. or you are using LLMs to do evaluation instead of using humans to do evaluation. And once you establish the baseline that LLMs and human raters are evaluating at par, say 90% of the time they agree on each other, then that's a huge reduction in cost,
Yeah.
also efficiency, and improves efficiency by several factors. So to sum it up to scale, distinctly remember you asked for scale. I can see two things. One is when you expand beyond English market, you can you instead of drawing a blank, you have a head start by using synthetic data. And then similarly, if you take, you can even if effectively replace humans in the loop as experts to evaluate search engines with large language models, which again, it's synthetic annotation or AI annotation as opposed to human annotation. Both of these reduce cost by, I would say, amortized value would be several millions of dollars over a period of time.
Yeah.
And
I think you hit on a couple really interesting points I'd love to dive in a little bit deeper. So first, you talked about the transfer learning use case, where you're trying to take things from one domain, let's say like the English language, and trying to take it to a little resource domain where you have less data available. And the idea was you could use a powerful LLM to do that translation. One of the really big areas of interest that we hear about today is like this move from like LLMs to SLMs, where you have small language models that are domain specific experts. And this case that you're talking about of, taking something from English to a low resource language is something typically you would start doing with an LLM. You may use that to fine tune an SLM to do something like much more efficiently or things like that. If you could maybe just dive in and comment a little bit about how you think about or how you've seen large language models being taken advantage of for what they do well, or small language models that are trained on a domain-specific context.
Why are we going after a small language model instead of a large language model? The simple reason is you don't need a heavyweight solution for everything. If your problem is confined and if your problem is well-defined. So you don't need a trillion parameter model. You can live with a few billions of parameter model if your problem is well-defined. And in these cases, if your problem is well-defined, it is possible to distill or train a smaller large language model, SLMs, as you said, to solve for that very specific niche. I think I'm going to quote, I forgot the name of the company. This is not my personal quote. I'm not able to give the credit because I don't remember the person. Predibase, yeah, the CEO of Predibase or founder of Predibase may said that for some very niche problems you can deploy SLMs because you don't expect the SLM to write a Shakespearean poetry with a twist with a 2900 AD twist. So because you don't have that use case, you can always fine-tune models for that very specific niche and solve for your problem. I'm not sure if I'm quoting him correctly, but the sentiment goes that you don't need your smaller you don't expect your smaller language models to come up with fancy poetry, and because you don't have that expectation, you can reduce the number of parameters. That makes it tractable. That makes it that also eases operationalization, as opposed to the cost of deploying a trillion parameter model versus few billion parameter models is vastly different.
Yeah,
so,
that's awesome.
Yeah, so I think the key idea is if you have a niche well-defined problem, it is possible to train a smaller language model, SLM, instead of with LLM as a teacher, the large language model as a teacher, and distill a smaller language model for that niche problem. And that way you reduce cost.
That's wonderful. And there was a second top point that you brought up, which I actually want to open up to both of you to hear your opinion on. You talked about this concept of like LLM as a judge, where you have an AI that you were saying, for example, that has probably been trained on the types of responses that you're expecting from human annotators that can be used to scale the human annotators at scale. I would love to hear from both of you, like any more comments, dive a level deeper on this, on like where you've seen it be successful, what types of ROI that it's been able to drive. Maybe Varun, I'll hand it over to you and see if you had any kind of initial thoughts on this, on areas that have worked really well, or areas to look out for as you start thinking about strategies like this?
I think it can work really well in instances of like when you want to do a triage. There's a flow of instances happening which need to be evaluated, and you want to replace human evaluation with a model AI model evaluation. So you could triage those applications that, okay, I trust this level of decision making that they're doing at a certain point, and then I'll have a human to evaluate that. So, for instance, credit risk underwriting. Underwriting is basically sometimes you have models. People like some banks may not have models, so they have credit officers going through all these applications, individual applications, and if they want to override a decision, they can override it. So it means like there are lots of people who are actually working and going through lots of documents, and which are PDFs, non-structured, unstructured data. So there is like a particular use case where this whole thing could be more streamlined, and there could be more operational efficiency achieved using this technology.
That's awesome. One of the things that I've heard about, is between LLMs, or even with the same LLM, there's a fair amount of, like, I think the term is stochasticity, but like a fair amount of randomness in the responses. And maybe going back, Raghavan, around the LLM as a judge work you've done, like, what methods and what level of success have you had? And any tips for anyone that's working with these LLM as a judge type techniques on like how to get consistent responses and how to think about those responses, as a complement to, for example, what you might have from human labelers?
I would talk about the challenge that everyone should look out for while doing this, and maybe a tip. The challenge to look out for is, first, define the agreement level that you want to reach between a human annotator and an LLM. For example, in the case of credit risk, I would assume it has to be 99.999% agreeable. But say maybe for search engine quality evaluation, I could live with 95%, 90%. And in some other cases, I might be okay with 80%. So establish that first. And once you establish that, the iterations is to establish the baseline of where that human LLM annotation agreement is, and iterate that until you reach that desired level. That would be my advice and tip, to say that embrace for that challenge, and so work on that. Once you achieve that, I think you would be able to make substantial progress. The second thing that I would say is, you may have to take a call on, because say LLMs, whether on-prem or you're going to use OpenAI or Azure or Cloud, whether you do batch inferencing or you evaluate multiple records, or you ask LLMs to judge multiple data points in the same call, or you're going to issue a separate call. That's another key decision that you may have to make, and that depends on your use case, the context length, the token limit of the LLM that you are using, etc., etc. So to sum it up, I would say establish the baseline of what level of agreement are you trying to achieve between the LLM and the human, and iterate on it until you reach the desired level, and then take a call on whether you are going to do one data point at a time versus batch evaluation. These are two critical decisions that you should take upfront.
Yeah, I think you hit on two big trends that we've heard a fair amount about in the LLM as a jury space, right? Like one would be LLM as a judge, LLM as a jury, which is where you have multiple LLMs that might be looking at that data point where you're trying to drive some level of consensus between them. So kind of very interesting piece there as well. And then also you were talking about evaluating multiple data points at once. And I would assume that is for context for the LLM. So it has other examples it could look at as well. If you could elaborate on that a little bit.
So LLM as a jury, in my personal opinion, why do you have a jury in the first place? To ensure that there is a diversity of opinion and you are able to get a collective decision, right? For a problem like search quality evaluation, I think that's an overkill. You could achieve the same amount of the same quality with a single LLM that is trained for this task, as long as the annotation agreement between the human and the LLM is say 95%, I'm just throwing the number out, then, and if you're tolerant for that 5% error, I think a single LLM would do instead of having multiple LLMs. But that's not the case for some other sensitive problem spaces like the finance and banking industry, where taking a call on credit rating could be a make or break for someone's life. So it depends on the use case. But for something like search use case, I would say start with a single LLM. If you can solve for that with single LLM, that's great. And then second question was, what was your second question? I forgot that one. Is LLM
the reason behind giving multiple data points to an LLM and batch processing.
It's just the latency and time taken. For example, any LLM is going to respond in several seconds. LLMs are not going to respond in milliseconds. So if you have, say, if you want to evaluate 100,000 data points, are you willing to wait 100,000 seconds versus trying to batch 10 at a time, and so you get 100,000 or 10,000 seconds. So
that's awesome. So maybe handing it over to Varun. Actually, I would love to hear your thoughts on that same question about like the LLM messaging approach and trading off that kind of compute complexity for quality of an answer, and how you think about that in the financial space. So maybe a quick comment on that, and then going to the next question for where you have seen ROI and scale within the finance industry.
Yeah, thanks, Alex. But unfortunately, I don't have experience using LLMs or in financial industry or otherwise, so I wouldn't be able to make a good comment on that.
Gotcha. Then let's jump right into areas where you have seen or that you see the potential for synthetic data to drive ROI specifically in the finance space.
Yeah, I mean, so like you have, especially in the US, there are a lot of smaller banks, and there are smaller credit institutions which are not even banks or other institutions. They don't have the modeling capability, and they also don't have a lot of data history for them to develop models which can drive better ROI for them, which can help their business grow with a proper risk adjusted, in a risk adjusted way to model their risk appetite, etc. All of that. So these smaller institutions, they either rely on vendors for to come in, like either they buy data from the vendors, or they rely on consulting companies who have basically worked with different other financial institutions, and they can pool and build something for them. So I think that's a really good use case. If synthetic data comes in and they can use it, that would drive the that would impact their P&L, because they're essentially not relying on spending, like their cost would come down because they wouldn't be spending on buying new data or relying on external consulting companies. Similarly, even for the larger banks, there are credit bureaus who have data on who's delinquent on their utility bills, who was having has a thick file, credit file, or a thin file, etc. All of that. So even that data is basically bought by banks to build risk scorecards. So again, there's this ROI that can be delivered if, rather than buying external data or buying pooled data, you can mix synthetic data with your own internal data and actually grow it as your internal data grows, get better estimates from the synthetic data as well. So develop an adaptive model rather than relying on just one particular solution, practically speaking. Then there are specific modeling problems where I see an ROI. So for instance, there's something known as loss given default. So to give you an example of a residential mortgage, you have a house, and the borrower is in default, like you cannot make your payments. So the bank, and if you cannot do that, then the bank has this problem of selling the property and then waiting for the property to be sold, and then getting a haircut on it, and then going through all the legal procedures, etc. So there's a foreclosure. That's what is happening. So the problem is to model that loss given default, that if there is a default, what is the loss that the financial institution can estimate. Now you can develop that model and we do that, but like there's a big time to recovery, because the recoveries for a mortgage will take a much longer process. So you can't. So there are challenges that if you have that model, how would you validate it against the actuals? Because there's a 24-month time to recovery, going through the legal costs, going through the time when the property is sold, etc., and all of that. So there are modeling challenges where we face that, okay, we have developed this model using past data, but we can't validate it, or we will have to wait a longer to collect data to model it. So if we could use synthetic data, we could shorten the time to recovery, which is a factor in developing these LGD models, and get probably not the best model at least, but like a model that you can use and save thousands or millions of dollars on capital, because you have a model that is working, may not be exceptionally working well as compared to having the actual data, but still working good enough that you don't have to wait for longer period of time.
No, that's awesome. Going right from there into challenges with synthetic data, and I wanted to ask each of you to touch on this a little bit. Vern, maybe we'll start with you. If you could talk about where you see the use of synthetic data being challenging, or what challenges you might come across in the finance industry.
Yeah, sure. So I have a use case where it's a long tail distribution, and you have one model. It's like you're modeling a downturn event, and downturn is like a 1 in 100-year event, or let's say 1 in a 50-year event, or whatever. So there's a tail distribution that you want to model. There's a loss that you want to estimate. So the way I did was I went through the traditional route of using Bayesian statistics. And Bayesian statistics has this advantage that you can get expert opinions, and also use the data that you have, which is the likelihood, and get opinions from different experts on the downturn, combine them, and have a posterior distribution that you can model. So there could be a way to challenge that model using a benchmark model, where you could use a GAN, like a generative adversarial network, and you would say that, okay, the bank hasn't gone through a downturn, the economy hasn't gone through a downturn in 10 years, so we don't have a downturn data in 10 years, but we have some actual losses in 10 years, which means I have a part of that distribution, loss distribution, and I could use synthetic data, and I could use my actual losses and get a better loss distribution. So the challenge which would come, this is a use case, but like the challenge would come, like how would you validate something like that? What is the best, could it be, first of all, could it be trained? Like, could you actually train a GAN on, let's say, 30 loss instances? Would it be robust enough? So there would be these quantitative challenges. You could mix, let's say, a kernel density estimation, which is a traditional method, and GAN, and show like a more robust validation. So then I foresee challenges in explaining such methodologies to the regulators, because if what you're doing is regulated, then you'll have to explain to 1,000 different stakeholders, internally or externally, and convince them, okay, this is a methodology which could be used, and it could deliver effective results. So before it becomes pervasive, I think it will take time, and then it will become more acceptable to regulators to be effectively used in actual business cases.
Very helpful, thank you. Raghavan, maybe on the flip side of that, if you could touch on best practices you would recommend for looking at synthetic data as part of an AI project.
Clearly define the goals and use cases. Before generating the synthetic data, understand the specific problems that you are trying to solve. Is it you are solving for data scarcity because it's a tail segment, or are you just trying to reduce the cost of annotation, or are you trying to improve model performance for certain languages? So identify the problem and clearly define the goal and use case. Second thing that I would say is validate the synthetic data thoroughly. You leverage domain expertise, keep humans in the loop, so that the annotation agreement, establish something like a CAPA score, so that the annotation agreement between the human reviewers and the synthetic data LLM as a judge is at a desired level. And in addition to that, ensure that there is some bias and fairness audit. For example, say if you just let synthetic data generation let loose, it could bring in other problems. So have checks and balances in place so that you are using it responsibly. And then lastly, I would say um, we talked about clear goals, and then continuous monitoring with keeping me human in the loop, and then for ensure that there is bias and fairness audits, and then ensure that you are also using a mix of both the synthetic data and the organic data at the right proportion, so that you are not over indexing or going to the other extreme of it's all synthetic now and there is no organic data inside. So to sum it up, establish your goals, understand your use case, and then secondly, have human in the loop to ensure that there is an audit, and then mix and match.
That's wonderful. Thank you. With just a few minutes left before we move over to the audience questions, I would love to ask each of you to touch on what you see as emerging or future trends for synthetic data. Where is it going? Raghavan, I'll start with you.
Synthetic data is going to be very critical for those use cases where it's very difficult to obtain any data.
Mhm.
So I see a lot of upside for computer vision style use cases where I have heard of startups whose sole product is generating that synthetic data of assembly lines, the images that you see of um, parts that are getting built in the assembly lines. So I see a huge upside for those industries where it's very very difficult to obtain data, any data set for any data for that point matter. And I also see there's a need for doing it responsibly, especially in those applications where it affects human lives and opportunities. So that's an area of research that would we would get to know new results and new ways of doing this synthetic data generation responsibly. So yeah, underserved markets because there is not enough training data, and then how to do it responsibly are the two areas that I'm looking forward to, where I see there will be huge growth.
That's great. Varun?
Yeah, sure. I think I have similar sort of thoughts. By responsibly, I think because the decisions that a financial industry makes impact the end, lives and economy and everything. So because of this high impact, I feel that it would be used in baby steps. So, for instance, it would not be directly used for a regulatory-driven model. It would be more for like a non-regulatory model, such as a risk scorecard, where you're accepting or rejecting applications. And it's okay that if you're making some errors in that judgment and in that decision, you could improve with time. But then, if it is a more stringent regulatory-driven model, then it wouldn't be acceptable to begin with. It could be used in peripheral areas of modeling, such as modeling validation, model monitoring, developing a benchmark model for a primary model, saying that, okay, I do have a benchmark model. What does it say about that estimate for which we are using the primary model? So there could be a challenge to that. I think these are the instances where it will slowly become adaptable, and depending on whether it actually delivers ROI and these models actually help and could be used under those strict regulations, I think it will take time, and then it will grow more to be included in a primary model per se.
It's very helpful. Thank you for walking through that. So before we hand it over to the audience for questions, I'll start with a quick summary of some of the big topics that we covered today on areas where synthetic data is most useful across both the search and the finance space. The long tail distribution, areas where you have a set of queries or groups that are underrepresented, the idea that you can use synthetic data to boost those and in a much more cost effective way than relying on manual collection, manual data curation, or labeling. Another one that Varun brought up was running simulations where data is lacking. So if you are a finance industry and you're considering a small bank, you're considering going into a new region, you may not have a lot of data for that region. So this could be a way to cost effectively and quickly build data to start to estimate what your credit risk or even fraud might look like in that region. Other things we talked about as being really important. And one of the ones, Raghavan, that you hit on that I really liked was like, know what you want to do, right? Establish your goals and understand your use case before you start experimenting with synthetic data. I think that's really great, great feedback. And we all talked about the importance of alignment between humans and the LLM to make sure when we are using AI to either create data or label it for us, to make sure that we've got some sort of a loop and a continuous check to make sure that we have alignment between the AI outputs and what we're expecting for our business. So I'd love to take a moment here and thank our panelists for joining today. Raghavan and Varun, thank you very much for the time today. And we'll jump right over to questions.